Hello there. This video will hopefully give you an understanding of Git that will make it easier for you to begin using it, or at least a strong foundation to learn more. What Git essentially does is allow you, with or without a team, to have a history timeline for the content of a project, stored along with that content. Some services will allow a project to be cloud hosted, which is handy for teamwork. You can have many people at once working on the same project while sharing that managed history. Git history tracks a repository, often shortened to repo. This is a folder with the project files you want to track a history for. The folder may be tracked from blank or at any stage of development after. To get started, you must first download a tool that works with Git. You may use any tool you prefer. I use Git Bash or cmder as I find console tools are easier to get help with. Check out the attached link for information on installs for your operating system. With Git installed, you can make a local repository where you keep all a single project's files on your machine. Even with a cloud repository, you would still make a local copy to make changes on. You can then choose to update the cloud with this at any point. Choose the folder that will hold your project, then open your chosen Git tool in that folder. When you initialize a new repo, hidden information relating to Git is added inside and the timeline can begin. To set up a new local repo, you can git init to initialize a new repo in that folder. If you are certain you will be hosting to the cloud, you could also start your repo there. I will start with a local repo now and move to the cloud to cover both options. I will add a readme markdown file at the root of the repo. This file is almost always present and describes what your project is to someone looking at the repo for the first time, along with some related helpful tips. Because Git is normally for code or projects that generate extra files, as well as confidential or user-specific configuration, I can add a gitignore. I will use the link site to generate a gitignore for Visual Studio C# console apps, as I'll add one later. You can see here the list of these folders or files that will be ignored in Git history. Git does not track history automatically. We call git commit to commit some changes to our history timeline. We normally make some changes that are timeline worthy, like our first commit here. First, we will take a look at how we can add files to be committed. Files that will be added to a commit are referred to as staged. You can see what is staged or what can be staged to a commit with git status. To stage some changes, use git add followed by a folder path, a file path, or add all with a full stop. I'll add all here. When you are happy with what you have staged, enter git commit-m with a short message describing what you have added in quotes. This has added a point in your history timeline with all you added being the event. I'll repeat, adding the console app, so you can see files targeted in the gitignore, such as bin, do not appear. Brilliant. You can use git log to see the commit history. Hit Q to quit back to console. You can put this data up on any cloud surface. I'll use GitHub. Most other services operate in a similar way. You need to create a new repository, which would be blank. If you have not started, you do have the option to add a readme and gitignore commit here. You choose public to share with the world, else private to limit who can access. When a repo is set up, it will have an address. You can push your local data up to this or clone the information to any machine. To get what we have to that repo, we need to get that address and link to remote with the git remote command, which sets that address as the target of git cloud commands. Let's just verify with -v. Great. Git push to push what we have locally up onto the cloud. You can now see our repo with code and our readme. Regardless of the cloud-hosted repo, if you have permission to copy, you may use git clone to pull it down from the cloud and work on it. Using a new folder to test, I'll call git clone, followed by the repo address, then wait for the download. It is also possible to get the latest cloud changes on already cloned code with git fetch. If I see there is a change to capture, I will use git pull to pull them down from the cloud. In a lot of cases, we need a branch of the main history timeline where you have the same base history, but the changes you make from then are only reflected in that branch. A new branch can be made on your timeline with git checkout. This command has other uses, such as looking at previous commits, but essentially lets you focus on or check out something. Let's check out a new branch. -b with a name will make it a new branch of that name and focus on it. Usually a branch is for a new feature, so we can name this Hello World. We can make changes in this branch and even commit them. And you can see if we check out the master branch, it's unaffected. When ready, you normally bring a feature into the main branch so that along with your main history, you have the feature code too. Git manages this with the merge feature. Changes present between the source and the target are compared, then any conflicts will cause a failure to be shown. Pulling changes from the cloud will also cause a merge between the cloud and local. Conflicts are often addressed by either manually resolving the conflict or basing your history off the most recent commits on the target branch using git rebase, which, if successful, will base the branch history on a commit after the conflicts. This, I found, is better managed outside the console. I find Visual Studio Code is a brilliant option. Regardless of the tool chosen, you need to look at the conflicting code and decide what your conflict addressing commit will take on board or erase. This is a complicated part of Git, usually only occurring working in team projects on the same files. With cloud repos, a pull request can alternatively be used to merge code, basically allowing repo owners or moderators to see changes, comment on them, make suggestions, or approve. This is normally used over a direct merge for quality control. Similar to a branch, you can make a fork of some repos. This is essentially an alternative history just for you to work on. You use this if you are not allowed to directly contribute to a repo with merging or commits, or possibly just to experiment with the codebase. A pull request can be used to bring a fork's history into the repo the fork was made from if needs be. I have only roughly covered the minimum needed to get started in this video, so I hope I helped you understand Git and set you up to try more features and tools as you need them. If you have any feedback or ideas, mention them in the comments. Check out the description for some links to get going, and thanks for watching.